My name is Cooper Montgomery Hardy, and this is a brief explanation of the superposition theorem, showing what it is and how it is used. The superposition theorem is used to solve complex linear or bilateral circuits, which are composed of multiple current and power sources, and components arranged in parallel and series. In the simplest definition, the superposition theorem removes power sources so that each power source can be analyzed individually, then each source is added together algebraically to finally demonstrate the effect of all power sources in the circuit. The first step of this method is to note any sources in the circuit. The second step in the method is to remove a source to isolate the other, remembering to replace voltage sources with short circuits and current sources with open circuits. The third step is to calculate the resistance against the source and use it to calculate the current over the resistors. In this case, it is just R1 plus R3, so 500 ohms. With this information, you can easily find the resistor currents by just dividing V1 by the total resistance against the source. Therefore, the answer would be 15 volts divided by 500 ohms, which results in 30 milliamps. This result would be the same over R1 and R3. The fourth step is to repeat this method for the other source or sources in the circuit. So first, you would isolate one source. The fifth step of the method is to calculate the current over the resistors. As this is a current source, we don't need to calculate the total resistance. We can go straight to calculating the current, which in this case, we can just simply use the voltage divider rule. The current over R2 will be the same as I1. To find the current over R1 and R3, you can use the current divider rule. This rule states that to find the current over R3, the currents over R2 must be multiplied by R1 over the sum of R1 and R3, which equals 12 milliamps. Then to find the current over R1, the current over R2 must be multiplied by R3 over the sum of R1 and R3, which equals 18 milliamps. These results seem accurate as the current follows the path of least resistance. The sixth step is to combine the current values over the resistors from both sources. You can see that for the current over R3, the values are subtracted. This is due to the direction of the currents. Finally, you can use these currents to find the voltage over each resistor simply using Ohm's law. That is simply how the superposition theorem can be used to analyze a circuit with multiple power sources. Thank you for watching.